In this lesson, we will be looking at arc length, defined by S, and sector area. Our objectives will be to determine the arc length of a circle using our radian measure, as well as calculate the radius of a circle given a central angle, and finally to calculate the area of a sector of a circle, again using our radian measure. Let's first work to understand arc length. Arc length is defined by this formula, where the arc length, this distance along the curve, is defined by r, which is our radius, times theta, which is our angle, measured in radians. If we are given an angle measured in degrees, we always need to convert that to radians in order to define this arc length S. Let's look at a couple of examples. In our first example, we have a unit circle. We have a radius of 1. If we're given a radius of 1 and we want to determine the arc length, we must first know what our theta is. So in this example, I have created a 90-degree angle. Hopefully right now you are thinking, what is that in radians? Well, in radians, remember that 90 degrees is a quarter of the way around a circle. The complete circumference around a circle, a unit circle, is 2 pi. So a quarter of the way around is going to be pi over 2. So our theta in this case is pi over 2. If we're looking at our arc length formula, we can define this distance here along this curve, along the circumference, S, is equal to our radius, which in this case is 1, times our theta, which is just pi over 2. So our arc length is pi over 2. Let's look at another example. In this case, same theta. Theta is pi over 2, but now our radius is 2. So now we would just need to double our theta. So 2 times pi over 2. These cancel, and our arc length is pi. And in our last example, we have a radius of 3. So we are tripling our radius, and we are also tripling our arc length, and we get 3 pi over 2. In these situations, you can use your calculator and convert this to a number with a decimal if it makes sense for the problem. Now let's look at an actual problem. So in this example, we want to find the length of the arc of a circle of radius 4 meters. So right away we know that our radius is equal to 4, subtended by a central angle of 2 radians. So our theta is measured in radians, and we know our theta is 2. Now remember, just because there's not a pi on our radians doesn't mean that it's not in radians. It tells us it's in radians, and our radians don't have to be in terms of pi. In this case, our radian is just 2. So using our formula, we would say that the length of the arc, or the arc length, is equal to our theta, 4 times 2, which is 8. Now think about what our units are. We are measuring our radius in meters, so this would be 8 meters long. So whatever our theta was, the distance here along this circumference is going to be 8 meters. We can assume that's our theta. That would be then 8 meters. Let's look at another example. In this example, we want to find the radius of a circle if the central angle measures 45 degrees. So in this case, we can draw that. Here's our central angle. And we don't have theta in radians yet, but we know that it is 45 degrees. And the arc length is 2 feet. So in this case, we're actually given the arc length, and we want to work backwards to figure out what our radius is. So take a minute and pause the video, see if you can determine what the radius is. The easiest way to figure out this problem is to set up the equation. So we know that the arc length is equal to r times theta, where theta is in radians. Now we can plug in what we know. We know that the arc length is 2 feet. We don't know our radius, and we don't actually know our theta in radians. So we need to convert 45 degrees to radian measure. So hopefully again you're thinking to yourself, 45 degrees, well that's half of 90 degrees, and 90 degrees we said was pi over 2. So what's half of pi over 2? We know that would be pi over 4 radians. So we can plug in pi over 4, and then we can solve for r by multiplying both sides by the reciprocal, which is 4 over pi. Multiply this side by 4 over pi. These then cancel or turn into 1, and we end up with an r, or a radius, of 8 over pi. Now that doesn't really make sense. So in this case, we would want to pull out our calculator and take 8 divided by pi, or 3.14 if we round, and we get an answer of 2.55. And our units were in feet, so this is feet. The key for these problems is just making sure that you're always using radian measure. And if you get a problem with degrees, that you first convert it to radian measure before you work out the problem. Let's go ahead and move on to area of a sector. Let's understand what this is and how we can find it. You probably remember in geometry finding the area of a sector using degrees. So up here is the formula that you might remember. Remember that if we take the entire area of a circle, we can call that theta. The entire distance around is 360 degrees. If we're just wanting to find an area of a portion, this pi right here in blue, then we would figure out what that fraction is based on whatever degrees this opened up to. So if this was 45 degrees, we would take 45 over 360 to figure out what fraction of a circle we had, and then we would multiply it by the equation for the area of a circle, pi r squared. But now we're working with radian measure. So if theta is measured in radians, then we have a different formula. So here's how it's derived. Instead of 360 degrees right here, we now have 2 pi as the distance around. So we're going to say that theta divided by 2 pi is the new fraction times pi r squared. Well, this is a rather complex equation, so let's simplify it. If we take our theta over 2 pi and we multiply it by pi r squared, we know that these pi's cancel and we're left with theta over 2, or another way to write that is 1/2 times theta, and still the r squared on the end. This is a nice, simple formula for finding the area of a sector in a circle. It's a little bit more simple than using our degrees. So let's go ahead and try an equation. In this situation, we want to find the area of a sector of the circle. So we know that our radius is 2, and once again we have theta in degrees. So pause the video and see if you can find the area of the sector of this circle. Well, remember that our first step would be to write out the equation that we need to use. Since we're not using degrees, we are going to use this equation, that the area is equal to 1/2 theta times r squared. Well, what is our theta? We already established that 45 degrees is the same thing as pi over 4, and then we know that our radius is 2, so 2 squared. Simplifying this, we get 1/2 pi over 4 radians times 4. Further simplifying, 2 goes into 4 2 times, and we are left with 2 pi over 4, which is the same thing as pi over 2. Because we're finding the area, I would go ahead and use the calculator and say that 3.14 divided by 2 is equal to 1.57 meters squared. So be careful not to get confused. If you see pi over 2, You might think, oh, that's 90 degrees. But we're not measuring the angle theta, we're measuring the area of the sector of the circle. So keep in mind what you're measuring, so that way you will interpret your solution correctly. And that concludes our lesson for today. It's really not too difficult. Just keep in mind that your theta needs to be in radians, but from that you can then calculate arc length and area of a sector.